Hello friends, today we are discussing the cube and cube roots part NCRT solutions for class 8. I've opened the NCRT for you. We will discuss few of the questions, few generalized questions that can come up in your exams that are more important as per your exam point of view, right? So the very first question that says is, which of the following numbers are not perfect cube? So I'm just solving the very first part of it. Let's check 216 first of all. For finding out the 216, we need to find out the prime factorization of 216. Let's quickly find out the prime factorization. So it will go at 2 at 108, then again at 2, 54, again 2, 27. Now it will go at 3, again 3, and again 3 ones are 3. So ultimately, 216 is 2 multiply 2 multiply 2 and 3 multiply 3 multiply 3. So you can see that 2 is there in a pair of 3 and 3 is also there in a pair of 3. So we can write down as 216 equal to 2 cube into 3 cube. Ultimately, we can say that this is equal to 2 into 3 whole cube, which is 6 cube. So 216 is a cube of 6. So we can say that, therefore, 216 is a perfect cube. Now, in the same way, you can solve each of the other questions here. Next, let's move on to question number 2. Question 2 says, find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube, right? So in order to obtain a perfect cube, we need to find the smallest number which we can multiply here, right? Let me take, I'm doing fourth part here for this question, which is 675. So first of all, in order to find out which number we need to multiply here, we'll find out the prime factorization only for 675. So 675, we can see that it is divisible by 3 as well. So 3 into 225 is 675. Then again, this is divisible by 3. 3 into 75 is 225. 3 into 25 is 75. 5 into 1, 5 into 5, sorry. And then 5 into 1. So we can see that 675 is actually 3 multiply 3 multiply 3 multiply 5 multiply 5. This is the prime factorization of 675. You can check that 3 is already there in pair, but 5 is not there in pair, right? So 5, here 3 can be grouped into the triplets, but 5 cannot be grouped. So we need to add one more 5 to make it a perfect cube, right? So we'll write down here 5 cannot be grouped into triplets of equal factors. So the smallest number by which we multiply 675 to make it a perfect cube is 5. Now let's move on to the next question. The next question says, question 3 says, by which number you should divide, by which smallest number we can divide the following numbers so that we obtain a perfect cube. So for the division as well, we need to check the prime factorization of a particular number and then the extra factors that we receive that we need to remove, right? Let's talk about question number 3. Okay, in question number 3, I'm taking the second part. 128. Let's do the prime factorization of 128. 2 multiplied by 64. 2 multiplied by 32. 2 multiplied by 16. 2 multiplied by 8. 2 multiplied by 4 is 8. 2 into 2. And then 2 ones are. So ultimately 128 is equal to 2 multiplied by 2. How many times? 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, and 7. Now, if we make the pairing here, 1, 2 is extra from the triplets pair, right? So we can just remove that 2 to make it a perfect cube. You can just write down pair 2 cannot be grouped in triplets of equal factors. So we'll divide 128 by 2 to get a perfect cube. Now question 4 says, Parikshit makes a cuboid of plastics with sides 5 centimeter, 2 centimeter, and 5 centimeter. How many such cuboids will he need to form a cube? In this particular question, what we'll do, first we'll find out the volume of the cube. The volume of cube is actually 5 into 2 into 5. The given sides are given us as 5, 2, and 5 centimeter each. So let's multiply them together. So that will be equal to 50 centimeter cube. Now we'll find out the prime factorization of 50 here. 2 into 25, 5 into 5, and 5 into 1. So ultimately 50 is equal to 2 multiply 5 multiply 5. So here 2, 5, 2 and 5 both are not grouped into the triplets part. So what we'll do, we need to multiply 2 2's here and 1 5 here to make it a complete cube. So we can write down here 2 and 5 cannot be grouped into triplets of equal factors. So we will multiply 50 by 2 into 2 into 5, that is 20, to get a perfect cube. So therefore we can say that 20 cuboids are needed. Hence, twenty cuboids are needed to form a cube. Next, we move on to the next exercise. That is related to the cube root part. In order to find the cube root, what we'll do, we always do the prime factorization method is only the way by which we can do the cube root. In question 1, I am taking the 9th part here. One 7 5 6 1 6 2. That is the 9th part we are having. First, we do the prime factorization of 1 7 5 6 1 6 here. It will go by 2. 2 8s are 16. 2 7s are 14. 2 8s are 16. Again by 2. Again by 2. It will go again by 2. Now it will go by 7. 7 into 49. 7 7s are 7. Now, if you talk about the prime factorization of 1756, 16, how many 2s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 2. 3 times 7. So we can check that it can be paired. 2 is 3 times pairing and 1 times 7 is pairing. So ultimately the cube root of 1756, 16 is from one pair, from one similar pair, we can take out one number. So from the first pairing, we are taking out 2, second pairing 2 again, third pairing 2 again, and from fourth pairing 7. Now 2 into 2 into 2 is 8, 8 into 7 is 56. So therefore the cube root of 175616 is 56. So this is the only way by which you can find out the cube root. Just find out the prime factorization of the number and then just quickly just make the pairing, right? I hope the chapter is clear to you. Now we are having few true false questions. Let's quickly solve them also. We are having 7 parts. 1, 2, 3. Okay, let me read the statements one by one. Cube of any odd number is even. If you take any odd number and if you find out the cube of that number, suppose 3. 3 cube is 27, which is not even, which is odd. So this is a false statement. If we talk about the second statement, a perfect cube does not end with 2 zeros. It's true, a perfect cube never ends with 2 zeros. A perfect square ends with 2 zeros. So this is true. Next is, if square of a number ends with 5, then its cube ends with 25. If you find the square of a number which ends in 5, suppose 5 square. 5 square is 25. It is ending with 5. Now, if we find out the cube of that number, 5 cube, 625. Okay. Let us take some other example also. If I take 15, right? If I take 15, so 15 square is 225, right? And if we talk about, it is ending at 5. And if we talk about 15 cube, that is 3375. This statement is false here. Now 3375 is not ending at 25, right? Let's come to the fourth part. There is no perfect cube which ends with 8. So I think 2 cube is ending at 8. This is the false statement. 2 cube automatically ends with 8. Even if you take 12 cube, that the unit place of that number is also 8. Next is, the cube of a 2-digit number may be a 3-digit number. It can never be a 3-digit. It will be always be more than 3-digit. It will be 4-digit, right? This is also false. Let's move on to 6th part. The cube of a 2-digit number may have 7 or more digits. This is also false. The cube of a single-digit number may be a single-digit number. So if you talk about the cube of a single-digit number, 1 cube, 2 cube, 3 cube is 27. Maybe, because they have written maybe, that can be true, because 1 cube is 1, 2 cube is 8, but 3 cube is 2-digit number. This is true. We have just over with the discussion of this chapter. So thank you so much.